Welcome to Intro to SQL for Excel Users, Part 7, Basic Groups. I am your instructor, Dave Langer. I like to begin the tutorials in this series with some housekeeping. First up, if you don't have the software, if you don't have the database that you need to conduct this tutorial, these two videos are what you need right here. This first video here shows you how to get set up for free with SQL Server and the database used in this tutorial on a Windows machine, for example, your own laptop or your own desktop machine. If you're using Mac, or if you prefer to use the cloud, this is the video for you. Once again, this shows you how to get set up for free using Microsoft's cloud, which is known as Microsoft Azure. Next up, all files for this tutorial series are in a GitHub, specifically github.com/daveondata/SQL for Excel users. All of the files for both the blog and YouTube tutorial will be located here, and there will be a link to this GitHub in the video description. The subject of today's video is basic groups. Grouping is extremely important. If you've been using Excel for any length of time, you implicitly know this. So some of this might be remedial for you, and I apologize for that, but I like to start very simple and build up so that this tutorial will be useful for a broad audience. So here we are in the Excel file for Part 7, SQL for Excel Users Part 7.xlsx. And I'm on the filtered data worksheet. And what we see here is just the 120 rows of the fact call center table from our AdventureWorks data warehouse database. The easiest way to think about groups is by thinking of a table and by a very simple and very common Excel operation, and that is filtering. Filtering establishes groups of data for you to look at. So for example, I can go up here to the shift column, and I can say, look, you know what, I want to filter it so I'm only looking at PM1 records. And lo and behold, Excel is more than happy to just give me this grouping of data. I have all of the columns, but only the rows corresponding to the group PM1. That's a basic group. You might not necessarily think of it that way, but it is in fact a grouping. So much so that I could actually just say, you know what, I'm going to create a new worksheet and I'm only going to have two columns in it. I'm going to have only shift and level 1 operators. And you can see here that I've filtered this down to just PM1. And I've only done this just to make things a little bit simpler and easier for people to see. And I'll even zoom in a little bit in Excel on this. So you can see here that I have all of the rows for PM1. Now, with this grouping, even in Excel, even with just a basic table, I can use filtering to create a grouping, and then I can do interesting things with it. So for example, if I click on column E here, Excel will actually create some calculations for me automatically for this grouping. So for example, down here you can see average 2.7. So the average number of level 1 operators for the PM1 shift group, the average value is 2.7. You can also see here that there's a count 31 cells total, and the sum is 81. Even with just out of the box Excel tables, you can automatically create some interesting things. You can create the average, you can create the sum, you can create the count. You can say, look, with this group, I can start doing some calculations on the group. As you guys well know, if you've been using Excel at all, yeah, this is kind of cool and it's kind of interesting and it's kind of helpful, but what is Excel really famous for? The mighty pivot table, of course. So what we can do here is we can say, look, you know what? Creating calculations on groups of data is so useful that Excel's primary features, one of its primary scenarios, is creating what is known as a pivot table. And essentially that's just working with groups of data and then doing calculations, summarizing the data in various ways based on the groups. So let's go ahead and do that. So on this table, I can just go, hey, Excel, give me a pivot table, will you? And put it in a new worksheet, click OK. I won't even bother naming this for the time being. And we can say, okay, cool. We've got all of our data ready to go for pivoting. So what we want to do is we want to say, look, I want my shifts to be my groups along the rows. So if I drop it down here, Lo and behold, I get each individual unique value. Okay, this is super important. By default, Excel treats text data as categorical when you use it in a pivot table. There are many rows in the original table that have a shift value of AM, midnight, PM1, or PM2. However, when you drop it in on a row, it automatically says, oh, okay, cool, I'm only giving you the unique values. Or if you put it in the column, same thing. It's saying, look, I'm going to go through, find all the distinct unique values, and I'm going to use those as categories. I'm going to use those as groupings. So I'm going to go ahead and put this back in the rows, and we've got our groupings here. And if we're really interested, we can say, look, I'm interested in the total number of operators by shift grouping. And you can see here, okay, cool. I got 81, just like we saw before on the previous worksheet for PM1. At the midnight, we only have 21 total across all 120 rows. We only had 21 midnight level 1 operators, 56 for the AM, so on and so forth. Y'all get this. Pivot tables are awesome. They're one of the primary reasons why people use Excel, right? You just drag and drop and you do all kinds of cool and interesting things. So like, for example, that particular pivot table isn't that interesting. So let's add a better one. Let's add a more interesting one. So we'll just go ahead and create another pivot table. And we'll put it over here. And once again, we're going to put the shift on the rows. But this time, we're going to do some more interesting things. We're going to say, okay, what is the sum of the level 1 operators? That's the default summarization function, the summarization calculation that Excel gives you out of the box when it detects a numeric variable type. It just says, I'm going to add them up. But we can do other things. What is the minimum level of level 1 operators? So for each grouping, go through all of the rows of data for that grouping and find what was the smallest number of level 1 operators in a particular row for a particular grouping. So what we do is we drop this bad boy down here and we say, oh, you know what, let's change the function. Let's change the summarization function to min. And you can see here, boom. So apparently there was a midnight shift in the data where we had no level 1 operators. Well, that's kind of interesting. Okay, cool. Let's see what the max level 1 operators might be. We drop that down here, and we switch over to the max. Boom. And you can see 2, 3, and 4, which is interesting, right? So it's like, we don't have a lot of level 1 operators going on here. That could lead us to ask other questions like, well, let's compare them to level 2 operators. So we can put level 2 operators down here. Let's say, whoa, hello. We got a lot more level 1 operators going on here. Those are the kinds of things that you can do with pivot tables. Now, as you might imagine, creating groups from a table of data and then being able to create summarizations, particular calculations, the sum, the min, the max, the average, all of these things can be done in Excel pivot tables because it's wildly useful stuff. So as you might imagine, not surprisingly, if it's wildly useful in Excel and you could do it out of the box relatively easy in Excel, you might imagine that you can do it in SQL too. And that is exactly the case. That's where we use the mighty group by in SQL. Group by is analogous to using a pivot table. It's not 100% the same, but conceptually, a very basic pivot table like we see here can be simulated in SQL using what's known as group by. So let's flip over to SQL and I can start to show you what I mean by that. Here we are in SQL Server Management Studio, SSMS, and we're going to start playing with the mighty group by. And the reason why I use the word mighty to describe group by is because when you're using SQL as an analytics professional or any sort of professional, maybe you're in HR or IT or finance, I don't know, it doesn't really matter. Any sort of professional, if you're using SQL to work with data, more often than not, you're using group by. You use it all the time when you're analyzing data or pulling data from a database so that you can analyze it. You're using group by. You're using it all the time. So here we have a very, very simple snippet of SQL. So if I highlight just this part here, ignore the group by for a second. I know it's mighty, I know you're probably excited by it, but just pretend like it's not there for this exercise. So if I highlight it and I execute the code, I get back 120 rows because we know from previous videos that there are 120 rows of data in the fact call center table. So I'm just saying, hey, SQL, grab all the rows from fact call center and I want to use the alias FCC, for example. And the reason why I get back all the rows is I don't have any filters. I don't have a where clause on this particular snippet of SQL. SQL says, okay, Dave, sweet. I'll give you back all the rows of data. And then it says, Dave, what do you want out of all these rows of data? And I say, hey, I just want to select the shift. So I get back 120 rows. If you remember the pivot table that we saw in the previous section, you can simulate what we saw on the very first pivot table when I dropped shift, the shift column of data, onto the rows aspect of the pivot table. We just got back the distinct individual values for shift. And you can see here, lo and behold, I do the same thing. So this is the first logical mapping between an Excel pivot table and using the mighty group by. Literally what this does, this clause right here, group by, tells SQL, hey, go through the table, go through the fact call center table, and find me all of the distinct unique values of shift. And what I want you to do is create buckets for them, or groups. And think of this just like what you do in an Excel pivot table all the time. If you drop a string column, text column, onto the rows section of the pivot table, what you're going to get is something like this, right? The distinct groups, the unique values. Same thing. This is exactly what happens in the same thing with SQL. Now, what happens also too is once you do this, once you say, hey, SQL, I want to group by something, SQL says, cool, Dave, I'll do it for you. But here's the thing. If you're going to make me group by something, you have to select it. You have to have whatever you group by has to be in your select list because it's saying, look, you're telling me to group by, so you have to have the groups. So let's say if I did this, right? I want to select the level 1 operators from fact call center and I want to group by shift. If I run this, SQL's not going to be happy about it. Boom, right? It is angry. Look at this red. It is angry. Because what it's saying right here is saying, look, level 1 operators is invalid in the select list because it is not contained in either an aggregate function, and we'll get to that in a second, or, and this is the critical part here, or the group by clause. If you ask SQL to group by something, you have to make sure that it's in the select list. It is the law. You have no way around it. So now we've got the first part of our pivot table. We've got the groupings. We've got the groupings that we saw earlier. Here's the thing to remember. These groups, this shift grouping, is coming back in order. It's coming back in alphabetical ascending order. One quick thing to note here. By default, SQL Server databases are case independent. So even though this is a lowercase m, SQL Server doesn't make a distinction by default. It just says, look, I don't care if it's uppercase or lowercase, they're just the same. It's case insensitive. So A comes before M comes before P, whether it's capitalized or not. That's why you get it back this way. Given that, you might think that SQL automatically sorts things for you in the right order, and it doesn't. Sometimes, like in this example here, the data comes back in a sorted order, but you are not guaranteed by SQL to have anything that you pull back from the database to come back in any particular order. So it's always smart to always enforce ordering if you want your data to be sorted in some sort of order. So let's go ahead and introduce a new piece of SQL here. It's real simple. This is called the order by. This says, okay, the final results that come back, I want you to order them, SQL, by the shift column in ascending order. That's what this means. Order by fcc.shift. ASC means ascending. DSC means descending. We're going to go ahead and leave it in ascending order. This is good practice. You should never rely on SQL magically returning you back data in the order that you want. You should always explicitly tell SQL how you want the data ordered. And this is what you need the order by clause for. Now, here's the thing. Remember, we've talked previously about the logical processing order of SQL queries. Order is done last. So here goes. SQL says Dave wants to grab all the data. That's the first step of the logical processing. Cool. It then checks to see, does Dave have any filters? Nope, he doesn't. But he wants to group, so that's what happens next. So the data gets grouped. Finally, we select, and then lastly, we order. So that's the 4-step logical processing that is happening with this query. Pull the data, there's no filtering, so you get all the rows, group it, select it, order it. So now we've got this, we can just run it, and the results are exactly the same. My whole point is, though, is that when you start writing more complicated queries than this, you can never assume that you're going to get the data back in any particular order. Always, always, always be explicit if you need the data sorted for whatever reason. Okay, so this is not looking so much like our mighty pivot table that we saw in Excel. So let's go ahead and start building that out. So in Excel, as we saw in the previous section, you can create a pivot table. And when you drop a column of data from your table into the values section of the pivot table user experience, the UI, you get a sum by default if you're using a numeric variable. But if you noticed, I was able to actually change it and say, well, I don't want the sum. I want the min or the max or the average. Excel comes out of the box with a lot of summarization functions that you can use on the numeric data in your pivot table. These things, these summarization functions, their analogous construct in SQL is what's known as aggregate functions. And they work basically exactly the same way as they do in an Excel pivot table. They say, okay, cool. You've got a grouping. Within that grouping, I can go ahead and find the sum, or I can find the min, or I can find the max. And lo and behold, look at this. Notice how even the names are analogous to what we saw in Excel. Sum, min, max. Okay? These are aggregate functions. I'm going to quickly pull up a website here. This is from Microsoft's website. This is from the documentation for SQL Server. And you can see here are the aggregate functions, right? And there are a whole bunch of them. You can see them right here. There's the average, there's the count, there's max, min, standard deviation, sum, variance. So all the kinds of things that you would see and use in an Excel pivot table also exist in SQL as well. They just happen to be called aggregate functions. So let's go ahead and run this piece of code so we can actually see the output, because that'll help with the discussion here. Okay, cool. Now you'll notice that these numbers exactly mirror what we saw in Excel, in the Excel pivot table. For the AM group, the sum of the level 1 operators is 56, the min is 1, and the max is 2, just like we saw in the Excel pivot table. Once again, though, notice that we have no column names. Remember, this is a recurring theme that we've seen so far through the tutorial series. Most of the time, if you're creating a new column from scratch, which we're doing here because we're using an aggregate function, we're saying, hey, SQL, for each group, AM, midnight, PM1, PM2, sum up the values of the level 1 operators column for each group and spit those totals out for me. And SQL says, cool. But it has no way of knowing what that column is, so it doesn't give it a name. So as we've seen so many times before, we're going to need to give it some names with an alias. So let's go ahead and do that. It's pretty easy. You've seen this syntax before. I just add these right here and run it. And lo and behold, we get this, which looks very much like what we saw in Excel before we flipped over to SQL land. This looks very much like a pivot table. So the group by clause, this portion of SQL here, is mighty. We're going to see this more than once throughout this series. Group by is wildly useful. You're going to see it all over the place. And here's the good news. If you know how to use pivot tables in Excel, using group by makes total sense because they basically work exactly the same. They are conceptually the same. All right, that's it for today's video. I hope you're liking the series. I hope you're getting value out of it. If you are, please subscribe to the YouTube channel. I will be releasing 2 videos a week on YouTube until the YouTube series catches up with the blog series, which is right now around 21 blog posts. So that should be 21 YouTube videos. Until next time, please stay healthy, and I wish you very happy data sleuthing.